Hey guys, my name is Mohammed, and today I will teach and demonstrate an experiment on Gay-Lussac's law. There are 5 different laws that chemists use today, and they are Boyle's law, which is P1 times V1 equals P2 times V2, Charles' law, which is V1 divided by T1 equals V2 divided by T2, combined law, which uses everyone's law, which is P1 times V1 divided by T1 equals P1 P2 times V2 divided by T2. And you can also take out which variable you don't need, and you get your equation. Then there is a ideal law, which is P times V equals nRT. N in this equation is the number of moles or mass. And then there is Gay-Lussac's law, which I will be talking about today. Gay-Lussac's law states that the pressure of a given amount of gas held at constant volume is directly proportional to the Kelvin pressure. As the pressure goes up, the temperature also goes up, and vice versa. For my demonstration, I will be doing an air pressure can crush. In this demonstration, I will have a flame, an empty can of soda, and 2 cups of ice cold water. First, I will add a quarter of water in here, about this much. Then I will heat my flame to high speed. You will need a pair of tongs with this. You take your can, you will place it directly above the flame. You will approximately need to wait about 2 minutes or so till you hear it bubbling, and you can also Now I will flip this can over when I do it and put it upside down into the ice cold water. And when you do this, the can will crush. And now the can has been crushed from air pressure. I will be doing the 5 gas law questions. So the first one we're going to be doing is Boyle's law. The question says 2 liters of a gas is at 740 milliliters of mercury pressure. What is its volume at standard pressure? So this is its equation for Boyle's law. Now we can start plugging in what we have in the question. So for pressure 1, we have 740 mmHg. Then we have 2 liters. And we have to find out our volume. So we're gonna boot out our volume, and we're gonna boot out our pressure, and the pressure is gonna go under the P1 V1. So our pressure is at standard pressure. We're using milliliters of mercury, so it would be 760 milli. Right. And now we're going to find out for volume. So now we would do 740 times 2, which would be 1480. That we would take the 760 and divide that by 760, which would equal 1.95 liters. So this is the practice question for Boyle's law. Next question we're going to be doing is Charles' law. So this is Charles' law, and it states, the question states, is a 600 milliliters sample of nitrogen is heated from 27 Celsius to 77 Celsius at constant pressure. What is the final volume? So in this, we're trying to find the volume. We have volume and temperature. So it would be V1 over T1 equals V2 over T2. In this, we're going to start plugging in, but first we have to find out the volume. So what we're going to do is we're going to do V1. So what we're going to do is we're going to be cross multiplying. So we have to. So first, what I usually do is I convert the milliliters into liters. So we're going to use King Henry died by drinking chocolate milk. So we are at milliliters right now. We need to go to liters, which is base. So 1, 2, 3. So for liters would be 1, 2, 3, which would be 0.6 liters. And at the bottom would be 300. And then for our second temperature would be 350. And this would be X. So now we're going to be cross multiplying, and it would be 300 X equals 210. So what we're going to be doing is we're divide both sides by 300, and X would equal, volume 2 would equal 0.7, but this is in liters. If we want to, it would be 700 milliliters, but I keep mine in liters, so it would be 0.7 liters. So that is the answer for this question. So now we're going to be doing Gay-Lussac's law. The question says a gas has a pressure of 0.37 atm and at 50 Celsius. What is the pressure at standard temperature? So we're trying to find the pressure, and the temperature is going to be standard. So we can automatically put 273 Kelvin as our standard temperature for T2. So we have 0.370 atm, and we have to add 273 to 50 so we can get our Kelvin. .323 Kelvin. And now we put an X for our P2 because we're trying to find our pressure. So we could put 323 X equals it would equal 101.01. And we're going to divide 323 to both sides to get our pressure. So it is pressure 2 equals to 0.32. And this is our answer to Gay-Lussac's question. So now we're doing the combined law, which is Charles' law, Gay-Lussac's law, and Boyle's law all combined. And for this, we have our volume 1, and we have our pressure 1, and we also have our temperature 1. And we have our temperature 1, temperature 2, and we also have our pressure 2. So we're going to be trying to find our volume 2. So we're going to plug in as you can see, this is the equation for combined law. So now we're going to plug in what we have in the question into the equation. So we have 500 liters. And we have 700 mmGH. HG. Alright, and for our temperature is we have to add 273, which would be 473 Kelvin. And so now we're trying to find our V2. So what we're gonna do is we're gonna put for our pressure is, so our pressures in here are not the same. So what we could do is we're gonna make the milliliters of mercury into ATM. So it's a really easy process. You have to do your T-chart. So 700 mmHg equals to 760 at standard temperature would be mmHg to 1 ATM. So you would do 700 divided by 760. And it would be 0.92. So we got our pressure at the same ATM. So what is a volume? So we have, so it would be 293 Kelvin, and we would put an X right here. So what we do is we would multiply these two and these two together. So that would be 0.92 times 500, which would be 460 over 473 equals, which would be 300x would be 293. So now we cross multiply. So what we would do is we would do 300 times 473, which would be 14,900, which would be 141,900. X equals to 134,780. And we would divide it to both sides. So, and our answer would be 0.95. So our volume would be 0.95. So now we would do 740 times 2, which would be 1480. That we would take the 760 and divide that by 760, which would equal 1.95 liters. So this is the practice question for Boyle's Law. Next question we're going to be doing is Charles' Law. So this is Charles' Law, and it states, the question states, is a 600 milliliters sample of nitrogen is heated from 27 Celsius to 77 Celsius at constant pressure. What is the final volume? So in this, we're trying to find the volume. We have volume and temperature. So it would be V1 over T1 equals V2 over T2. In this, we're going to start plugging in, but first we have to find out the volume. So what we're going to do is we're going to do V1